Hi, Mina, Tsubasa des! Yay! Welcome to Coding 101, where I'll happily teach you the fundamentals of programming from scratch. This series welcomes everyone exploring this form of technicality, whether you're a zero experience total beginner or an experienced developer. So, welcome! Yay! So, without further ado, let me introduce you to this series. So, let's first address the elephant in the room. And Tubasas, why learn all of this when AI is mainstream? To support that, I'd like to quote this from Kuya Dev and from his The AI Guardrail podcast that he importantly stated that vibe coding is very probabilistic and traditional programming is deterministic. Simply put, vibe coding is AI generating the code for you, whereas traditional programming is you writing the code. Probabilistic is by random chance, like a dice roll or a gacha pool. So there's no guarantee your output will be the same. Deterministic is where your unique output is predictable and will always be the same no matter how many times you'll approach it. I'd like to get this distinction out because these two philosophies of how you code currently coexist, where before the latter used to be the only way. I'll walk you through in depth on what these two approaches to coding are, starting with vibe coding. First, let's define what vibe coding is. This is you conversing with an AI to generate code, but you don't necessarily have to be technical or know how to code. The keyword here is describe. You describe what you want to build with natural language. Think of it like you're the boss and you request to your IT department, "Hey, can you implement a function that would scan these documents automatically?" It's similar to you conversing with AI. Hence, coding becomes intent and context driven. Because you talk in a natural language and the coding speaks a technical one, the implementation may not be what you had in mind and it may take several outputs to achieve that. So the very first thing in this pipeline is your prompt, which is your input. Again, in natural language, you are describing what you want to see, like you're the client commissioning to someone. Because vibe coding is all about being descriptive, a good prompt is usually rich in detail and going from being broad to being specific. You describe as much as possible in great detail on the flow, the requirements, the scope, the do's and don'ts. You try your best on painting a good picture of what you want. A bad prompt is vague and makes the AI leave a lot of room for imagination, like make me a calculator program in HTML and CSS, or create a native POS system for me. There's a good chance that you'll never get what you actually want with bad prompts. On the other hand, a good prompt is down to the specifics of what you want. Here, for example, defining a calculator that handles basic arithmetic, limiting decimal point inputs, and showing the history of past calculations. It's long and exhausting, and there's no right answer for this, but you'll get a better chance of being satisfied with this output later. Essentially, overthinking with your prompt is usually good. After submitting your prompt, it, of course, gets processed by AI. The quality and the work at this stage is influenced by two things. One is how relevant the AI model that you're using and how it's trained. And two is the quality of your prompt, your input. The AI then predicts the most probable outcome it thinks you're expecting. At the end of the pipeline is your output. The AI produces one of the many outputs it can think of. At the end of the day, you still have the final say if that's the output that you want or do you follow it up. You're the boss of what you want. It's just that coding becomes AI assisted. Now, what makes vibe coding probabilistic? Given your input, you're seeing one of the many results that come out. The first result that you'll get will differ from a second run, a third run, and so forth. Let's take that concept with an analogy of going to a restaurant. So, you walk to a restaurant and here we have waiters on my left. Hello. And he approaches you and he waits for you to order. Now, you don't have the time to think of what food you want. and you thought of getting some recommendations from waiter-san. So you ask, what can you recommend for me? Waiter-san would be like, oh, how about our hamburger? When you try to ask the same question again, what can you recommend for me? He then thinks of something that you would like from the menu and say, oh, perhaps our salad with this dressing? Then you're still not satisfied with the first or second recommendation. So you ask like 99 times more, what can you recommend for me? And then he's kind of like on the edge and be like, does the fish and chips sound good to you? Eventually, you will have found the first thing that you wanted. Of course, Waiter-san thinks all of their menu servings are good. Waiter-san persuaded each item from the menu randomly, hoping that you'll eventually pick one of all the menu items. Is that what you truly wanted? Here we laid out the recommendations that we received. Now remember, Waiter-san walked me through a random linear list of menu items. And I just happened to pick the very first thing that I liked out of everything that he recommended me so far. However, there could have been a better dish that I could have picked if I kept asking Waiter-san for more recommendations. That's why there's still a pile of cards here after choosing the fish and chips. But I just so happened to rely on Waiter-san's random recommendations. When we follow that analogy, the same thing happens when you try to prompt this example. Write a Python code that displays the text "Hello World" one letter at a time on 3 separate sessions. We know this isn't a very good prompt, but this is to demonstrate just how probabilistic vibe coding can be. So I prompted this to ChatGPT, and here we have 3 sets of codes for this prompt. So let's run this simultaneously. Oh, when you look at it, the first and third one is exactly what I had in mind. I'm not satisfied with the second one since it just printed each letter on a new line. Notice how context in your prompt matters. Like, how do you want to display the text? Since our prompt is vague to begin with, AI already had 2 different outputs for us. Perhaps even more beyond these 3. I just so happened to resonate more with the first output. Notice even the comments also varied between the first and third prompt. This describes the probabilistic nature of vibe coding. Your prompt can result in many outputs, and each will have its different set of implementation, the bugs, the errors, and how it's presented. So imagine if you were doing this on a bigger scale. And that's how vibe coding is probabilistic as a whole. The idea is around randomness and by chance. Again, your input is going to generate different sets of outputs by the AI, and it's never going to output one and the same code. Now, how about traditional programming? This is coding everything by yourself. However, you also get to plan how is it going to be implemented. You're not just the boss, but you're the one who's going to do the heavy lifting of implementing what you need. In the traditional programming pipeline, the first thing that you have to do is to think of your plan. Unlike vibe coding, where you're describing what you want, in traditional programming, you kind of have to work yourself towards what you're trying to code and walking through your specifications. Your plan always starts with an idea, then you expound from your idea, then you lay out every step, every input, every outcome as much as possible. For example, you thought of coding a calculator program. Of course, we all know that a calculator has 4 operations. From that idea, you also know that an operation runs on only 2 numbers. And to make that idea a little flexible, you thought that all numbers in the calculator should have numbers in decimals. This is one of the many ideas you can think of in a calculator. But this is enough to advance what happens with your plan. So from your plan, you take your ideas and translate it as to how your programming language leverages your implementation. For example, with my calculator, I organize my calculator operations using functions or blocks of code per operation. Next, I define that my operations only take on 2 digits. Finally, since I explicitly defined all numbers in my calculator to have decimals, so I know that's a floating point integer, which is different from a normal integer without decimals. Finally, your output after all of that is your own crafted application. Yay! However, that's not the end of it. Since your input, the plan that you made, will never change or vary, no matter how many times you execute your input, the output will always be the same. That means even if you wrote the same calculator program in another language, the output will be one to your original calculator program. Everything is the same from the features, the style of coding, to even the bugs that you will have or will encounter. With your plan, the output never changes and will be certain. What's only going to be different is with the different languages come different syntax you must adapt. Just like here, when we implement each operation as a function in Python, it can be translated into C or somehow refactored in BASIC. So that's traditional programming in general. Now, how is it deterministic? Deterministic, by definition, is given a sure set of inputs will always result in the same output. It's one-to-one, meaning there's no randomness or variation. It's predictable and can be reproduced. This is in stark contrast to probabilistic vibe coding, where there's one-to-many code outputs, and its randomness results in many different code outputs coming from an input that is your prompt. Let's go back to the same restaurant example with Waiterson here again. With a deterministic mindset, I already know what I'm going to eat. So I come into the restaurant and I thought, I kind of wanted chicken this time around because I ate pork the other day. And I like to spice it up, I guess, and I wanted it to be creamy. So that's already your idea on what you wanted to eat at the restaurant, even without looking at the menu. When you piece what you specified, you thought, it's the chicken curry they have here. So that's what I ordered from Waitersan and he's happy about it. No fuss. No matter how much I repeat what type of food I want to eat, it's always going to be chicken curry. Even if it's another Waitersan or in this case, Waiter-chan here. Or another restaurant that just so happens to serve chicken curry. With this same analogy, that's what makes traditional programming deterministic. Now, let me demonstrate how traditional programming is deterministic. So, we take the calculator example that we went with earlier and I wrote it both in C and Python. Let's start here with C. Previously, we planned that the calculator has operations as distinct functions. And here is how I wrote it in C. There are 4 functions here with each of our operations: addition, subtraction, multiplication, and division. And each function returns the result of operating on those 2 numbers. Next, I took some little more effort and made the menu a function. This displays the list of operations, waits for the user to choose among the 4 with numbers 1 to 4, and the user's choice will be read and correspond to one of the 4 calculator operations that we defined earlier. Finally, we also plan that all numbers in our calculator must be in decimals. Hence, we tell C that each function here specifies a floating point integer with this float keyword. It means this function will return a number with decimals once it returns a value. Lastly, we have the obligatory main function in C and C++. This dictates the actual flow of your program from start to finish. Here, the user is asked for 2 numbers, takes these 2 numbers to the menu, then to the operations, and prints the result back to the user. Okay, now we compile and run the program. So let's try out our calculator here. As you can see, our calculator works just as expected. Then you suddenly thought, what happens when I divide by 0? So let's try that out. Let's choose 4 and the result is infinity. Huh. But we actually know that we cannot divide a number by 0, so this result is false. So we know that when we divide by 0, we just don't do that operation at all. So let's go back to our code and we see that here we're missing a check to see if that second number is 0. Let's add a simple condition following that rule. Now let's try the same example that we tried earlier. And there we go. As you can see, you know all the 4 operations. You write it in the language of your choice, you run it, you try dividing by 0, your program errors out or returns a false result, you patch out that one bug. Everything is according to plan. I can prove that it's the same with my calculator here in Python as the one I coded in C. It's the same style and layout with all the functions, only that this differs in syntax. For example, Python doesn't explicitly need a main function, so after my functions, I linearly start the program with the user inputs and run the menu. You may have noticed that, like earlier, I didn't properly code my division routine. If we try to run my Python program and do a division by 0, as expected, trying to divide any number by 0 and the interpreter will error out. But I know how to fix this in C, so I just have to adapt it in Python. Now when we try to do the same example again with the calculator, now accounting for that division by 0 rule, it will error out, but the program will exit gracefully. And now my calculator in Python is just as good as the one I did in C. You're determined on how you planned, designed, and implemented your calculator. If you implement this in another language, it's going to be the same flow, the same logic, the same conditions, the same bugs. You've seen how I have the same bug in the two languages where I wrote my calculator. Ultimately, the common denominator here are my ideas, and it will be the foundation of how I implement my ideas from now on. Everything corresponds 1 to 1. 0 divided by 0 will always be a division error. 1 plus 1 is always equals to 2. Again, no matter how much I repeat this process, it's always going to be the same output. And that is how traditional programming, coding by yourself, is deterministic. With all of this, one is not better than the other. AI is probabilistic and it depends on how rich you prompt it, and it depends on how each unique output will satisfy you. Coding problems yourself is deterministic. Sticking to how you approach the problem will always result in the same output. So yeah, don't let AI discourage you. One thing in common among the two of these philosophies is that you are the pilot and AI can be your co-pilot. In Coding 101, the fundamentals and concepts here apply to whatever language or software development you'll pursue. Understanding concepts are put first and foremost so that you can apply it to your own liking. You'll learn what it is before how you can apply what you learn. For codes and demos in this series, I want to showcase it in C. Personally, I think it's one of the most elaborate languages out there that you can learn a lot from. Of course, I'll also show counterparts of these in Python. I'd like to think that learning C is like learning how to drive in manual. Then once you mastered C, learning Python would be a breeze. Like you're now driving an automatic car. You'll learn more about programming languages later in this series. Speaking of programming languages, it's best if you stick with learning all about coding in one language, especially for first timers. When you master one, you mastered it all. It's just a matter of another language with just differing syntax. And practice matters. So, for me, practical real life projects are the one place to start. There's everyday problems around you that can be solved by technology. So, you may want to start looking around on how you solve these everyday problems, and that would be a problem you'd solve with code. And here's to just the introduction to Coding 101. This is more or less the format that this series will follow, and I hope you'll have a great time learning how to code with this series. If you want to support me and my future progress, you can tip me on coffee, and I'm on Blue Sky, so you can follow me there as well. So until next time, minasan, bye bye.